Welcome back to Catalyst University. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. In this video, we're going to go over something that some people have been very, unfortunately, confused and misled by. And to be honest, it's really not intuitive, and it's not even true. And that is that it's the infamous sum of all counting numbers is equal to negative 1/12. This is not true. And I'm going to explain to you why this is not true and what this means, the sum of all counting numbers. That's this S right here. If you basically added 1 plus 2 plus 3 plus 4 plus 5 and just added up and up and up and up, apparently it should equal negative 1/12. Well, I'm going to show you first the quote-unquote proof of this fact, apparently, that it equals negative 1/12, because unfortunately to disprove it, you kind of have to go through this proof first. So I'm going to explain what they did to actually arrive at this erroneous result. Now, first of all, before we go into it, why does this not make sense? Well, if you've taken any calculus course in the past, or you might not even need that, what intuitively should this sum equal? So if you added 1 plus 2 plus 3 plus 4 and just added basically out to infinity, well, it should equal infinity, right? So a few things are really confusing here. First of all, you're adding whole numbers. You're only adding positive whole numbers. So one key there is whole number. So if you're adding a bunch of whole numbers, how do you get something as a fraction? And second of all, you're adding positive whole numbers. So how is the answer negative? If it doesn't work based on logic, it's probably not right. Well, let's dissect into this and figure out why it's not right. So the question is, we want to answer what this series, the sum of all counting numbers, is equal to. Okay? To do this, I'm going to define some other series for you. I'm going to call this one Series 1. And this series is just going to be an alternating series where it's positive, negative, positive, negative. But it's going to be 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, and just goes out to infinity like that. Well, this is my series. Let's look at a partial sum list. So this little s with the p, that's partial sum, and this is for S1, okay? So if I look at only the first number, that's obviously just 1. If I then take 1 minus 1, that's 0. And then if I add 1 to that, we're back to 1. Subtract 1, we're back to 0. And you can see that this pattern of partial sums is going to repeat forever. 1, 0, 1, 0, 1, 0, 1, and so on and so forth. Okay? And what they said in these videos is they said that because it alternates between 1 and 0 out forever, and it just repeats this pattern forever, we can say that the sum is just the average of these two numbers, 1 and 0. And obviously the average of 1 and 0 is just 1/2. Well, that's the first mistake. We'll go over why that's a mistake at the end of the video. But apparently the sum number 1 is 1/2. Okay? Let's now define another series. We'll call it Series 2. This one's a lot harder to look at because it's not as intuitive, apparently, what the sum is. So we have to do some algebra. All right, here's the second series, Series 2. And it's defined as 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7, so on and so forth. So basically they're just adding all these numbers, but every other number, i.e. all the even numbers, are negative. All the odd numbers are positive, and it just goes on and on and on and on. Okay? Let's look at the partial sums for this. First number, obviously just 1. I'm going to subtract 2, then I'm over to negative 1. Okay? Add 3 to that, I'm at positive 2. Subtract 4, I'm at negative 2. Add 5, I'm at positive 3. And this pattern is just going to repeat over and over again. So it's going to go from 1 to negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 5, negative 5, and so on and so forth. What's sum number 2? This one's not as intuitive, but let's see if we can figure something out. And what they did is they multiplied S2, this series 2, by 2. They just double it, all right? And sometimes in math and physics, you kind of just play around with numbers. There's nothing wrong with that. You can just try weird things and cool things happen. Nothing wrong with that. And if you're assuming that this sum is right, S1, nothing wrong with doing this. Double S2, we can add these series together. But we're going to do it in a slightly a mischievous way, so to speak. I'm going to add S2 to itself, but I'm going to shift all the numbers over one to the right. Okay? So the 1 is under the 2 is under the 3 is under the 4, and so on and so forth. Let's add them together. 1 down to 1. Negative 2 plus 1 is minus 1. 3 minus 2 is 1. Negative 4 plus 3 is minus 1. And so we get this series, 1 minus 1 plus 1 minus 1. Well, we've seen this before. That's series 1, which I aptly have labeled here. So apparently, if you add S2 to S2, or in other words, double S2, that's equal to S1. And so I have that formalism written right here. 2S2 is equal to S1. Well, we already found out what S1 was. That's 1/2. So therefore, 2S2, or 2 times series 2, is equal to 1/2. And if we divide through every side by 2, we can get that series 2 is apparently equal to 1/4. Okay? Now we know series 1 is apparently 1/2, series 2 is apparently 1/4. Again, in the same spirit of what we just did up here, where we just kind of just played around with some numbers, we're just going to play around here and do something weird, and maybe something cool will happen. We're going to take the original series, this is the one we want to determine, and subtract S2 from it. So what was this original series? 1 plus 2 plus 3 plus 4 plus 5 plus 6, so on, so forth, which theoretically should diverge to infinity. And we're going to subtract S2, which is 1 minus 2 plus 3 minus 4, so on and so forth. I've rewritten it up here for you. What's 1 minus 1? 0. What's 2 minus a negative 2? That's 2 plus 2, which is 4. 3 minus 3, 0. 4 minus a negative 4 is 4 plus 4, which is 8. And this pattern is going to keep repeating, where every other number is 0, and the numbers between the zeros are all multiples of 4 consecutively. So 0, 4, 0, 8, 0, 12. We would keep going 0, 16, 0, 20, 0, 24. And we just keep going. Well, since we don't care about zeros, we can get rid of the zeros and condense this. The series we want to find, S minus series 2, is equal to 4 plus 8 plus 12, so on and so forth. Okay? Now, because every one of these numbers is a multiple of 4, I'm just going to factor out a 4. You're allowed to do this. If I pull out a 4, I just get 1 plus 2 plus 3, and that makes sense. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on and so forth. But hey, this 1 plus 2 plus 3 and so on and so forth, that's S. That's the series I want to find. So I'm just going to replace that whole bracket with just S. And now, I know what S2 is. It's apparently 1/4. So, if I subtract this 4S over here and move the S2 to the other side, S minus 4S is negative 3S equals S2, equals series 2. Well, series 2, like I just said, was apparently 1/4. So negative 3 times the series that we want to find, the sum of all counting numbers, is equal to 1/4. If I divide both sides through by negative 3, the sum of all counting numbers, notice it's boxed in red, is apparently negative 1/12. And that is supposedly the proof that if you add up every positive number, basically, every positive whole number, you get a negative number, and at that a fraction, negative 1/12. All right, so the question is this right? Is it valid?
No.
This is not true, and let's talk about why it's not true. Okay, let's actually start with S1. So, when you have a series and you're adding the terms together, and you get partial sums like this, 1, 0, 1, 0, 1, 0, 1, and this would obviously just repeat over and over and over and over again, 1, 0, 1, 0, 1, 0. So you could let this go on infinitely long, and this series, series 1, would never converge to a single value. It just alternates between two values in a predictable fashion. So this series, even though it's not going up to infinity or negative infinity, this series does not converge. Therefore, you can't just say that the series 1 is just 1/2 the average of these two numbers, 1 and 0. No, this series is undefined. It has no sum. Sometimes you would actually see this written as just no sum. But it's undefined because it's consistently alternating forever between 1 and 0. It's not the average of those two numbers, it just has no sum. It's undefined. And by the same argument, since series 1 is undefined, and it's not just 1/2, remember we used this value to determine the value of series 2. So if this 1/2 is not valid, and it's certainly not true, then this 1/4 is also not valid and also not true. In fact, we don't even need to know that. We can just look at S2 independently, and it's also no sum or undefined. Let's think about it for a second. I have this pattern of 1, -1, 2, -2, 3, -3. Eventually I'd get to 1 million, -1 million, 1 billion, -1 billion. And if you let it keep going, you would get up to positive infinity and then negative infinity. It would just swap between the two values, positive infinity and negative infinity. And so for that reason, it doesn't converge to a single value. It actually alternates between positives and negatives. Okay? If in order for it to go straight to infinity, it would have to all be positive leading up to positive infinity. It can't alternate between positive and negative because it keeps flipping across the x-axis. And so because it would never settle on a single value, either infinity or positive infinity, it cycles between both of them, this also has no sum and is therefore undefined. Okay? We wouldn't even say this diverges. It has no sum, it is undefined. It's undefined because it doesn't have one single value. Okay? Now, the original series that we're talking about, this one is just infinity. And really and truly, it's really a logical argument. You don't need any real calculus even to prove it. You add a bunch of positive numbers together forever, it's just going to go to infinity. If you took all these numbers, the 1 and all of them, and just made them all negative, so -1 plus -2 plus -3, it would diverge to negative infinity. Okay? So there is no proof that this is a negative fraction. That's not true at all. It's as simple as it looks. It just goes to positive infinity. These other two series, the values that were derived from whatever proof it was, are not valid, because these two series do not converge to a single value. They don't diverge even to a single value. They don't have a single value. They're undefined, or they have no sum. All right? So, sorry to burst anyone's bubble here, but the sum of all counting numbers is infinity. You could also say the sum of all negative counting numbers is negative infinity, but it is not -1/12. So hopefully this video cleared up any issues that people were having with the infamous sum of all counting numbers. Please make sure to like this video and subscribe to the channel for future videos and notifications. Thank you very much.